This lecture title is Landslide and Debris Flow Hazard in the Indian Himalaya. An overview. The contents of this lecture are the geographical overview of the Indian Himalaya, micro donation of landslides in India, the factors and causes of landslide and debris flow in the Indian Himalaya, road-induced landslide hazards in the Indian Himalaya, rain-induced landslides and debris flow hazards, a case from Kedarnath disaster. Last content is strategy for landslide and debris flow hazard management and mitigation. The geographical overview, if we talk about geography, the total geographical area of Indian Himalayan region is 5.37 lakhs square kilometer. Administratively, it covers 10 states, entirely GIAN, Himachal Pradesh, Uttarakhand, Sikkim, Arunachal Pradesh, Nagaland, Manipur, Mizoram, Tripura, Meghalaya, and 2 states partially. These are hill districts of Assam and West Bengal. So these areas, these districts, states are comprising Indian Himalayan region, or knowing as Indian Himalayan region. You please note down even everyone this. Can you now after some time clean it? I have already discussed in my earlier presentation categories of landslides. Rain-induced landslides, earthquakes-induced landslides, road or man-induced landslides. Now, one important aspect we have missed so far, that is developing a capacity for landslide prediction. Okay? So, very important. The landslide hazard donation effort will be greatly enriched by developing a capacity to predict and forecast landslides. For landslide prediction, the following classification is generally useful. First, number 1, first time slide. If we will have the information of a particular landslide, then we have to know the first time landslide, when it was occurred, at the first time. Second important is reactivation of old dormant landslides. Third, known landslides of the recent origin and seasonal landslides. Fourth, flow slides. The prediction usually means answering the following questions. Where would a landslide occur? Question number 1. Fourth question. How much would be the anticipated maximum levels of displacement and displacement rate? So these questions, answer of these questions are very helpful for predicting landslide events. Now I will focus on some facts about landslides. Some reported observations in the Indian Himalayan region clearly reveal an average of 2 landslides per square kilometer per year. A general rate, so far observed, so far studied, 2 landslides per square kilometer per year. Second fact, the loss due to landslides and debris flow in the Himalayan region alone constitutes about 30% of the world's total landslide related damage. A big amount. Third fact, along the Indian Himalayan region, landslides occur extensively, substantial negative impact, particularly on human life, productive agriculture land, domestic animals, infrastructures, and heritage sites. Consequent to the Himalayan uplift and subsequent stabilization of the southwest monsoon, the region experienced heavy rainfall, mostly concentrated to the monsoon season. Localized heavy precipitation, cloudburst, often takes place in the region, resulting in the landslides, debris flow, and flash floods. Factors and causes of landslide, very important. First, if you know what are the factors, what are the causes, if you concentrate on these items, then we will be able to get some solution of this landslide and debris flow hazard in our region. The Himalaya provide a high energy environment where steep slopes, high relief, tectonic movements with high seismicity, highly jointed fractured bare rocks, high physical weathering, occurrence of unconsolidated quaternary sediment along hill slopes, high precipitation gradient, deep cutting of rivers, valleys, unique hydrological conditions, and overall increased anthropogenic activities are instrumental in causing landslides and mass movements. Important factors and causes are: number one, increase of cold water pressure due to high rainfall or as a result of percolation leakage from canals, underlying water pipes, sewage pipes, etc. Number two, increase of weight in the upper part of the slide due to sediment due to sediment accumulation, deposition of debris from earlier slides or rockfalls, or due to man-made structures. Likewise, reduction of weight at the toe due to toe erosion or removal of the material during developmental activities. Next factors is increased internal pressure due to chemical or physical alternation like the swelling of clay, freezing of water. Next, dynamic forces like earthquakes, new tectonic activities, avalanches, blasting of rocks, passage of heavy vehicles, etc. The last one is unscientific land use like agricultural activities on steep slopes, shifting cultivation, overgrazing, deforestation, unscientific mining, and quarrying. These are the factors and causes of landslides, in spite of tectonics and neotectonic activities. Now we will move towards the major main landslides which are induced by the human activities. Road construction is a very important factor of landslide activities in our Himalayan region. What are the results? What are the outcome of this massive road construction in Himalaya? I will tell you some of the figures in quantitative terms. Road construction has played a significant role in balancing the landscape ecology and have created severe environmental deterioration of physical as well as cultural landscapes in the Himalaya. The road system contributed. I am giving an example from New Zealand, the rate of landslide debris volume. The road system contributed 750 to 800 cubic meter per kilometer per year debris to the local sediment budget. This is the rate in New Zealand. In Uttarakhand at Mussoorie of Central Himalaya, it was found that the road construction have contributed 5 to 10% increase in watershed sediment yield. Watershed is having an outlet at the lowest elevation there. Whatever the sediment budget means, all components of soil erosion through either it is through solution way, suspended way, bed road transport, adding all the sediment, that is called a sediment budget of a watershed. So it is landslide in a watershed is increasing 5 to 10% increase of sediment yield of a catchment. Our Himalayan region is a harboring network of watersheds, catchments, small catchments, big catchments, micro catchments. The construction of 44,000 kilometer long road. This figure was measured during 1985. Latest figure we don't have. The length of all the roads in the Indian Himalaya, that was 44,000 kilometers in 1985. Have generated 2,650 multiplied by 10 to the power 6 cubic meter of debris each year, every kilometer. Okay? Each year, every kilometer, this is the production of landslide debris. Produce 550 cubic meters of debris by landslides and rockfall. So that every 24 multiplied by 10 to the power 6 cubic meter of sediment slides down to the slopes, killing vegetation, smoothing springs and choking mountain springs and streams. The annual rate of sediment generation are reported by Border Road Organization is high as 724 cubic meters per kilometer on Jammu-Srinagar highway of Kashmir. These are the landslide volume production per kilometer per year rates from different sides of the our Indian Himalayan roads. Rain-induced landslide hazards. I will give you a very small, briefly example of recently disasters we faced in Uttarakhand. The Kedarnath disaster is the latest example of rainfall-prone disaster. That was heavy rainfall and burst of a glacial lake at Chorabadi above Kedarnath, and 3 times normal annual rainfall had fallen in the catchment of the Kedarnath shrine, triggering huge landslides never seen before in the region. This caused sudden floods that did not allow large number of pilgrims time to sail, and thus were trapped within minutes in the sand and debris of the river. Everybody seen that in the disaster in television in 2013. Landslides have now gained some value in the eyes of the government through this disaster. It is still not given importance it deserves. Even after the Uttarakhand disaster and death of thousands, protection from landslide is still not a priority item in the government agenda. I will tell you some of the figure of losses during that rain-induced hazard. Affected persons were 50 lakh persons were affected. Affected villages 4,200. Severely affected villages over 300 in number. Persons injured 4,463. Number of dead persons over 900. That is according to government. 8,701. 716. Number of roads destroyed 2,302. Number of bridges washed away 145. Number of drinking water schemes damaged 1,418. Number of villages without power due to that disaster 3,758. So these figures are showing the magnitude of its disastrous form, hazardous form. Okay? So, but our planners, decision makers, they have not yet started giving importance for this problem. If interdisciplinary research and teams should be integrated into disaster risk reduction DRR by analyzing hydropower dams, floods, earthquakes and landslides as well as glacial lake bursts from the higher Himalayas as it happened in Kedarnath case. There are about 100 topo sheets that require to be digitized for various data layers for Uttarakhand alone. Also, larger map data need to be available for inputs in the data layers at block level. This needs to be addressed by the government under Digital India campaign so that in the coming 5 years it gets in the research system deeply rooted. We don't have available yet digital topo sheets of any of the area. Some particular area digital topo sheets are available with the Survey of India. These digital topo sheets are very important for inputting in our GIS system. So even not from each and every part of our land. Now I will come to landslide mitigation and management in India. What is the institutional setup? Very briefly, landslide management in India is a subject which is being covered by the National Disaster Management Authority NDMA under the Union Ministry of Home. Act of 2005 has brought into focus the issue of disaster management in India. Possible national plan for landslide mitigation. The national plan for mitigation of landslide damages is being handled by the Ministry of Mines and Nodal Ministry, with Geological Survey of India as operative agency. The process of preparation of national guidelines on landslide and snow avalanches was made in 2005 through active participation of various organizations including GIS, GSI, CSIR Laboratory, CBRI, CRRI, DST, IIT Roorkee, IIT Guwahati, Wardia Institute of Himalayan Geology, and many others. They set the guidelines for all the states, for both the country, particularly for the Himalayan region, and they are available in NDMA website for our users. That is known as NDMA 2009, Management of Landslide and Snow Avalanches, NDMA Government of India publication, New Delhi. This publication is available in the website of NDMA. So this is the brief about the national level, and in state, particularly for Nagaland, we have NSDMA, Nagaland State Disaster Management Authority. In national level, NDMA. Okay. Now I will come on the strategy part for mitigation and management. What strategy we feel we must take it operative, effective. Establishing infrastructural facilities for studies on landslide and mass movement, and identification of the agencies which will be responsible for carrying out investigations and answering questions from the public. Provisions of specialization courses in landslide studies within educational institutions. So this part is also lacking with our with our polytechnic, with our IITs, with our universities, with our colleges, particularly on landslide specialization courses. Detailed maps of landslide zonation along highways and canals. These are urgently required, desperately needed. Establishment of National Database Center for landslide hazards. The data needs upgrading from time to time. Monitoring of prospective landslide prone areas through remote sensing techniques. We are rich in space technology, but users are in a very few numbers. Even our planners, bureaucrats, decision makers, they are never bothering about this technology. Mitigation measures. The landslide mitigation and control measures depend on detailed investigations, including identifying of the causative factors. Proper drainage should be provided for the removal of household water, particularly in the landslide prone areas. These are some important measures which we can implement. The netting of slopes stops the downward movement of the slope material. It reduces the impact of kinetic energy of raindrops and surface water, and even hold together slope material. Check dams control surface runoff and improve moisture conditions, essential for the growth of vegetation in the landslide affected areas. In the clay rich areas, grasses and bushes are used in order to reduce the overburden caused by the growth of higher plants. Check dams can also be constructed with rocks. Civil infrastructure should be used in conjunction with bioengineering for maximum benefits. Detailed field investigations should prelude the design of treatment measures. Community early warning system have proved successful in managing residual risk. That also we don't have yet. Rebuilding livelihoods and ensuring food security are equally critical. Thus, reconstruction should focus on these aspects. Capacity building of government agencies on treatment techniques is essential. creation of a working group which will be responsible for the development of a standard harmonized protocol for landslide inventory work. A moderated web-based platform for landslide inventory data. Development of metadata templates, standards for landslides. Formation of multidisciplinary interdepartmental working group which should include national and international institutions and individual experts. Develop landslide risk assessment maps at the watershed level with strong engagement of communities. Develop a simple harmonized methodology for landslide hazard assessment which consistently uses available parameters and is also cost effective. Capacity building of agencies at different levels, national, state and district level. Prioritize landslide hazard areas for intervention. Establishment of early warning system. Adoption of multi-partnership approach. Documentation and sharing of best practices technologies both in Himalayan region and across the nation. Development of new technologies, action-oriented research including climate smart and indigenous technology. Developments mandated with landslide related work should ensure they are up to date in disaster risk reduction approaches. So this is all for this topic. He is from college. Professor from college.
Good afternoon, one and all. I am standing here to thank especially the GIAN coordinator and our coordinator here, Professor Rewat and Professor Sharat. I'm sure it was a very difficult task to bring this GIAN workshop to Nagaland, and I'm very grateful to the two of them for bringing this to this remote area where we can learn so many things. And I am representing Fazal College, and I'm also under one project under RUSA. So we are around 5-6 of us here under RUSA who have been sent to attend this. And I was hoping to learn something, and after attending this 5 days of workshop, I have learned so many things, and special thanks to our Professor Martin, who has done so many work. I think we should give him a big applause for his work that he has done. Thank you so much. And attending this workshop, I have learned about this statistics. Because most of the time we feel that we are lagging behind this statistical analysis, but Professor Martin has done a very nice job to simplify it, and we have learned statistics during this workshop. So for that, I would like to thank our professor who has come all the way from England to deliver that lecture, and I'm sure we are 57 of us here, and all of us will have learned something from this workshop. So all the special thanks goes to our professor. So I'd just like to wrap up that on behalf of myself and our college also, Fazal College Workshop, we are thankful for this workshop, and I hope that this kind of workshop should come to Nagaland University every year. Thank you.
One more. Thank you, Dr. Vedan. It is my pleasure to call here Achira from Hyder Valley College. Please say something.
Good afternoon, everyone. Thank you very much for the privilege. Like I've said, on the first day, I was not aware of the workshop, and I just now he just invited me, and when I came here, I was like I said, I was not aware that this thing was happening, and after attending every day, I got a lot of knowledge. Especially this workshop was mostly practical oriented. So in near future, for small researchers as well as since I've just started my research work, it is very beneficial for me also. Thank you very much, sir, and thank you one and all.
I'll take extra time. I hope you will excuse me for that. Yesterday, I was lucky to present my PhD Viva, and that time, Professor Martin was kind enough to be present during my presentation. And for that, I would like to share my thanks with a small gift and on behalf of all the participants.
On behalf of all of us, Madam is giving this.
That's the biggest size we got here.
So very much our colleagues from Hyder Valley College. Please come forward and say something. Here.
Any suggestion, any modification, any comment, it's a feedback. You can criticize very comfortably. That is the idea. Putting it will not help us. If there is any comment you want to make.
She is our Assistant Professor of Environmental Science.
Very good talk to everyone. I'm grateful for this privilege and a very unexpected time to be standing here before you all. First of all, I would like to thank Professor Awad for taking all the trouble and care to organize such a big workshop and course for all of us, from where I'm sure all of us have learned lots. I would like to say special thanks to Professor Martinez for coming all the way from England to such a remote place as this. It shows how much you care for us people out here and how much you care for the environment. So thank you so much. And for me, I am a person of chemistry actually, and I have joined environmental studies, environmental sciences. So actually this is not originally, this is not my field, but then having joined environmental studies, I thought this is an opportunity, being here at the university itself. So I grabbed the opportunity and I came here, being here for all these days, and I've learned lots. So from you and from all of us, everybody who was presented here. So thank you so much to Sir and the organizing committee, everybody who was taking the trouble, and special thanks to Sir. That's what I want to say. Thank you so much and good evening.
And you would like to come here? Please come forward. No problem. I will invite one of the research scholar of this department to present his assignment. Please come.
Good morning, everyone. This is my plan day for determination of the Landslide system. First of all, let me start from where in this area where the landslide is this landslide is occurring in the area, whether it's in coastal area, hillslope, river bank. Coastal area, hillslope, river bank, or other places, maybe in the sand dunes also. Mostly in semi-permanent sand dunes. And again, where in this bands, it is, I'm going to define that whether it is the raw materials, it is of boulder plus fine sediment, clay, or fine sediments. And next one, when it is happened, the time of seismic activity, high rainfall, biological disturbance, high range of daily temperature, strong this one marine activity. And again, third branch, there are again two branches. First one is that it is going very sedentary or continuously, periodically, and very fast, like rockfall. And here, this one, it is flowing, or this one, sliding, or rolling, or falling. This is in the last branch. Here I am trying to define why landslide is happening. First, excessive subsurface flow. After the high rainfall occurred in one area, subsurface flow is created, and when this subsurface flow is in a very excess condition, the outside land portion, it starts sliding down. Second one is rise and fall of water. Due to rise and fall of the water, it may be in the coastal area or it may be in the river area. Sometimes landslides happen. When I was doing when I was preparing this one presentation regarding the Lake Volta. This is the largest artificial lake which is located in Ghana. Because of the construction of Lake Volta, 5% of the geographical area of that whole country is under water. And after creating the Okosombo Dam, this Lake Volta is created. And in the downstream, because of the decline of the water level, landslide becomes a common phenomenon. And deforestation, because of the deforestation, landslides is commonly happen mostly in the shifting cultivating areas. And overgrazing. Overgrazing is a very common problem of landslide mostly in the semi-arid and arid regions. And overloading also. Last one. Overloading.
Thank you very much.
So from now on, my lectures will include one more slide. It will be Sadalanda's 3.
Chandra Kumar Datta. N. Anurag. Please, N. Anurag. Imri Kuppa Jamir. I. Jamshir Lokumar. Kezadi Leno. Dr. B. Joy Wasima. No item Sadananda Singh. Jo Yun Tong Lee Otio. W Nokto Konya. Miss T Lutfishi. Miss Lapsa Konya. Miss Mercy Zimomi. Miss Damandala. Miss Masileno Liberi. Mr. Soklo Dev. Mr. Enzen Lode. Miss P. Liang. Miss Martin Nathaniel. Mr. Momo Kenny. Mr. Bokrambam Narendra Singh. Mr. Bong Yamo Izong. Mr. Webuzo. Miss Abitori Kenny. Miss Venuceno Senotsu. Mr. Ketil Luko Zitzo. Dr. Martin. Mr. R. Pendleton. Miss Temple Sauna Bowler. Mr. Inti Tongpang Longtar. Dr. Latungila Jamir. Mr. Ebuka N. Achumi. Anybody know their names? Is there any participants without the certificate? Thank you so much. Thank you to all the participants.
Thank you very much, Professor Barclay, for presenting certificate to our successful participant. I congratulate each and every participant for great success, and I wish you a very bright future.